Hi, I'm Beatrice Chibakova. I'm from Russia. I study at 6th grade. I can fold anything from this sheet of paper. I don't need glue or scissors. This is called origami, the art of folding paper shapes. Look, I made a paper crane. It's symbol of knowledge, patience, and the drive to become a master. You think it's kids' game, right? Well, you're wrong. Mathematicians and engineers have been studying origami for a long time. For example, they use it to fold materials needed in space, medicine, and architecture. Origami makes our life easier. It can also make solving problems easier. Let me show you how. A car airbag is hidden from our eyes. We don't think about how such a huge piece of fabric hides inside a tiny box. How does it fit in there? The secret is in the folds, which means using the rules of origami. Look at this. An earwig's wings are 10 times bigger than its body. Where does it hide them? A few years ago, scientists noticed how insects fold their wings. It turned out that the folding tricks people use in origami and the ones earwigs use are very similar, but nature's origami is even better. Now, this folding idea will be used to build robots. Just imagine a flying delivery robot that easily fits in your pocket, and when it's time, it unfolds the flies to the right address. That's cooler than carrier pigeons! But that's all in the future. What do we have here now? In geometry, there are problems you can solve by folding a paper in a few seconds, while it usually takes a few minutes. Let's do an experiment. Start the timer. How do we usually prove the sum angle of a triangle in 180 degrees? We use an alternate interior angles theorem. The theorem is proven. How much time does it take? It takes 3 minutes. Now, let's take a paper triangle and prove the same thing in 3 seconds. 1, 2, 3. We brought all the corners together at the bottom. The angles of the triangle perfectly match a straight angle. So, the sum of angles is 180 degrees. By the way, this is called origametry. It's practical geometry where origami is the main tool for learning rules. But remember that origami is also an art. You can make the most amazing shapes out of triangles. With origami, mathematicians have even learned how to solve impossible problems. It started in ancient Greece. Euclid, the first math theorist, had very few tools. A flat board was like a ruler. 2 sticks tied with a string were like a compasses. That was enough for Euclid to show how to divide an angle in half on paper without measuring. Yes, that problem is easy to solve, but how do you divide any angle into 3 equal parts without a protractor? For almost 2000 years, geometrists were stuck on this. In the 19th century, they proved it was impossible in classical geometry. Then, a century later, a mathematician showed up with a piece of paper. No hard calculations, no tricky drawings, just one fold after another fold. And finally, the angle is split into the 3 equal parts. First, we fold the paper in half, bringing the bottom edge up so they match perfectly. Then we fold the bottom part to the middle. Now we have 2 creases. Next, we mark one point at the bottom tip of our angle and another point on the left edge halfway up. We fold the paper so the bottom tip touches the lower crease and the second point touches the top edge of the angle. We mark where the folds cross. Now we fold the paper to connect the tip of the angle to the first mark and then to the second mark. Done! This solution is based on the rules of origami. Yes, just like real science. Here is another impossible problem from ancient Greece. Legend says, a terrible sickness hit a city. The oracle said, the plague would go away if the people built a new altar exactly twice the volume of the old one. You might think, what's so hard about a cube? The ancient Greeks thought so too. They took a ruler and compasses and go stuck. It's easy to make the side twice as long, but then the volume grows 8 times. To double the volume of a cube, you need to find a side that is the cube root of 2. You can draw a line that exact length with just a ruler and compasses. It was a dead end for the Greeks, but for an origami master, it's just a few careful folds. We fold the square in half and open it back up. Now we fold it so the corner touches the middle of the side, and we mark where it crosses on the left edge. This mark splits the side into a 2:1 ratio. We fold our square into thirds and mark the creases. Now we fold the paper so the bottom left corner touches the top side, and the mark on the bottom side touches the second crease. The corner that hits the top side splits it in the exact way we need. Now we can build a cube with a side equal to the cube root of the 2. This means the new cube has twice the volume. That's how easily origami solves the problem. A long time ago in Japan, masters thought there were only a few dozen origami shapes. But in the mid-20th century, a master named Akira Yoshizawa created an origami alphabet. He published about 500 patterns and opened up a whole universe of paper shapes. Today, mathematicians use computers to design origami patterns. Now, you can fold almost anything from one sheet of paper, from realistic deer and cacti to model houses. Next came complex origami. Engineers realized this is the best way to pack any object tightly. You can open it with one smooth move and fold it back up just as easily. This kind of origami is used to open solar panels in space. So, a kid game turned into a space technology, and then it came back down to Earth, becoming a part of simple, everyday things that we can't imagine living without.